what happens when you tell an egg a joke?
It
cracks up.
That's not funny. You should hear my Taco Bell joke.
My homie didn't like
My
that.
infamous Taco Bell.
That's gotta be top 5 all-time dad joke.
Nah, I got a better one. Hear my Taco Bell joke.
Is it school appropriate?
Kind of.
Then no.
I agree.
Then no.
We're in high school.
Mrs. Hill like
No.
this. Mrs. Hill like this.
Anyways, all right. So L5 today. Last new idea of the year. Last new one of the year. That means we're getting close. We're not there yet, though. However, I will tell you, we are not at the end of the year yet, which means you can't start coasting now because we're only here.
You gotta X that 14.
I know, I got extra 14. We're only here. We got 2 full weeks plus a day to go yet. But it's still, in terms of including weekends and all that fun stuff, we've got 2 weeks to go yet.
Why don't we?
Inserts. Yeah? Alright? So, just so you know, especially this third one, did you hand in L1 to L4 yet? If you haven't turned in any of those, which is probably 3/4 of the room right now, that hasn't turned in any of those, that's on you. You are not going to get better by not doing this stuff. Okay? You are not going to magically learn how to do this stuff without doing this stuff. Okay? You have to do. This is not a observatory type of a endeavor. It needs to be participatory. It means you got to participate in it. Okay? You got to do. You can't sit back and just say, "Oh, I'm never going to use this stuff. Where am I going to use this stuff? Blah, blah." You're going to use this stuff this week and next week and on your final. Okay? If you never use it again, that's fine. Okay? Just get out of the fact that we're solving problems. Okay? We're teaching you a way to go about logically solving a problem. With that being said, there are 4 problems for you to do on the L5 homework. Go for it. Ken, we'll give you the hardest of the hard questions. Ready? Number 1, what's the answer? 0, right? 3 plus -3 is the same as, because instead of writing plus a negative, we could write this as 3 minus 3, which is going to be 0. Now, if you've got 3 pencils and I take 3 away, we got 0 pencils left. Yeah. 0 pencils left. Watch it, number 2. What she said? Because -7 plus 7 is 0 also? Yeah. That's straight facts. Okay? Michelle. -14x plus 14x. Still, wait a second. How can they, all 3 of you got the same answer for all 3 of those? That's something not right with that. Also 0 right there. Yeah? Right? Those all zeroed out. Okay? Now, when I was walking around, I saw a couple of people write down 0x for that last one. Okay? But what is 0 times x? It's just 0, right? 0 times anything is 0, so we don't have to write the x there. Okay? Okay? So, step 4, Ash. Step 4. Problem number 4. So we're solving by substitution. If we look back 2 pages in our notes, we have 2 boxes that have 5 steps in them, right? What does step number 1 tell us that we have to do? Have we that done here in this problem? Do we have one of the equations solved for one of the variables? Yes, we do, right? Because the first one is y equals. Okay? Right? So the first one is y equals. So then I was just up here with my good friend Bryce, and Bryce and I put a box around that part. Right, Bryce? Is that what you did? That was a genius idea. Great idea. Okay? Jake, what do I do in step 2 now with said green box? It's an S word. Substitute. What am I going to substitute the green box for? In the other equation, right? Yep, so I gotta go to the other equation. I can't stay on the same equation. I've got to go to the other equation, and then it's gonna be plus, and then I'm gonna say negative x plus 3, and then I'm gonna say that that equals 7. Love it. Yeah? 7. What would you do next? It's actually step number 3. We're going to solve that, right? Do I need this set of parentheses around these two? No, right? Because it's just plus 1 out front, right? So I don't really need that. So we could rewrite this as 2x minus x, right? Because plus and minus, we don't write that as minus x, plus 3 equals 7. Love it there. What would you do first then? What is 2x minus x? 1x, yeah, it's just 1x, right? Yeah. So we got x here, then plus 3 equals 7. 2x minus x became 1x. Okay? Chloe, finish it off for us. Got to subtract 3 from both sides, right? And what do we get, Chloe? X equals 4. Love it. We're going to put a little circle around that. Okay? Dylan, we just got done with step number 3. What does step number 4 tell us to do? Okay? So I got to take blue circle, and I got to put it back into either the top one or the bottom one to get out our y value, right? Which one do you want to put it into? Top one. Okay, I would also choose the top one because it's already y equals, right? So then that would become y equals negative. Now instead of x, we're going to put 4 and then plus 3, right? So negative 4 plus 3 is how much? Give me another chance. Because remember, here's our 0 line. Negative 1, right? Because we're starting down here, we're down 4, we had 1, then we're at negative 3, we had 2, we're at negative 2, we had 3, we're at negative 1. Okay? So we got y here equaling negative 1. Oops, I'm going to put a little circle on that one too. Love that, love that. Awesome. Step number 5 told us 2 things. What was one of the things that step number 5 told us? Check our answer. We could do that one first. Yep, we can do that first. So I got to plug in 4 in for x, and I got to plug in negative 1 in for y. If I plug in negative 1 for y and positive 4 in for x, I get negative 4 plus 3 is, and then negative 4 plus 3 is negative 1, and those are equal. That one checks out. If I plug in 4 for x, that's going to give me 2 times 4 plus a negative 1. And it's got to be 7. 2 times 4 is 8. 8 minus 1 is also 7. So that one checks out there too, right? Okay. Jake, what was the second thing that step 5 told us? Check was one part of step 5. Very important, because now we know that we're right. We know we got the right answer. Now we just got to give the right answer in the right way. X comma y, right? So what's our final answer going to look like? No? 4 comma negative 1. Yes. 4 comma negative 1. And we've already checked it, so we know 100% right now that that's right. So we can put a circle around it because Lacho and I were talking earlier. We do all this work. We don't want to lose our answer in the middle of the problem. You know, we want it to pop because we know we're right. We're proud of the fact that we're right. Okay? And so we want to tell everybody, we want to shout it from a mountaintop that we're right. That the answer to this one is 4 comma negative 1. Okay? Love it. So, Today what we're going to do is we're going to continue to solve systems of equations. Last week, a week ago, we solved by bracket. And that was one way to solve. That's one tool in your toolbox to solve systems of equations. And then last week, Thursday, and this past Monday, we continued on with substitution. And that's another way to solve with systems of equations. Okay? All right? Hey, get up, walk around the room. Because I'm not going to have you sleep in here. So get up and walk around the room. I'm not lying. Get up and walk around the room. No, you're not awake. You are so not awake. This, I swear to God, this was just you. Until I came over. Okay? So if you're going to fall asleep, get up and walk around the room. Okay? Third way is today. It's called elimination. Now, elimination is my personal favorite way of solving systems of equations because I don't have to graph anything. I don't have to solve anything. Okay? I just got to do. Okay? But I got to do in a specific way. So here we go with example number 1. It's at the bottom of your page. I'm going to give you steps, and then I'm going to do the steps at the same time. Okay? So step number 1 in elimination says that we need to get opposite coefficients. Okay? We need to get opposite coefficients on a variable. Now, what does the word opposite mean? Negative and positive. So one of them has to be negative. And one of them has to be positive. Okay? And they gotta be the same number. Okay? So we want them to be the same number, just one of them positive and one of them negative. Okay? So, looking at number 1, I need to look at coefficient. Remember, well, here's another word that we don't know. What's a coefficient? Tom, what's a coefficient? Because we need to have the opposite coefficient. We better know what a coefficient is. We've talked about it for weeks. Should I open it up to everybody? Anybody, what's a coefficient? We got, well, the number in front of the variable. Okay? So we need the same number, only one of them positive and one of them negative, in front of one of the variables. So if both x's have to be the same number, one positive, one negative, or both y's have to be the same number, but one positive and one negative. Do we have that done for us? Chloe says yes. Why, do you agree that we have this step number 1 done for us in this problem? Yeah, because we've got a negative 2 in front of the y in the top equation, and we have a positive 2 in front of the y in the bottom equation, right? Okay? So right here, we've got that done for us, because we've got a negative 2 and a positive 2 in front of one of the variables. In this case, it's y. Okay? Might not always be y, might be x at some point in time. Okay? All right, so that's step number 1. And we'll go through a problem here on the back side where we show you how to get it, how to manipulate it in order to do that for yourself. Okay? Step number 2 says now all we've got to do is literally add those 2 equations. I'm going to draw a big line underneath. I'm going to add those 2 equations. Okay? You ready? If I've got 5 x's and I give you one more x, how many x's do you have? If you have 5 x's already and I give you one more, you got 6 x's, right? So this becomes 6x. Now, sir, if you've got negative 2y's, and I give you 2y's, how many y's you got? If you already have negative 2 and I give you 2.
Negative 4.
You have negative 2 and I give you 2. You got how many? You got 0 y's. That goes away, right? Right? That's what elimination is all about. You are eliminating one of the variables. So the y's are gone from this new equation. Okay? Cora, if you've got 4 of something and I give you 8 more of something, how many somethings do you have? You got 12 of something. Yep. And then that equals 12. Okay? Now, notice the setup also. Notice how we've got x's all lined up, y's all lined up, equal signs all lined up, numbers all lined up. Okay? That makes that adding of the equations much easier to do. Okay? We've got everything all lined up. Okay? Step number 3 is the same as our substitution step number 3, and that says we're going to solve this new blue equation. Okay? Bryce, how do you want to solve this new blue equation? 6x equals 12. I want to solve it for x. 5 by 6, right? Yep, we can divide both sides by 6. And that's going to give us x equals what, Bryce? 2. X equals 2. With me so far? Okay. All right. Step number 4, EBR, says that we're going to substitute this that back into one of our original equations. Exactly like we did with substitution, right? Yeah, I'm not going to let you answer because you look like you're all stuffed up. You got the pollen going on and the ragweed, and you're just allergies. Yeah, I get it. I understand. We'll make Edwin answer the question. Edwin, top or bottom? Top or bottom? Where do we want to substitute in?
Top.
Top one? Okay. So Edwin has chosen the top one. So that is 5x minus 2y equals 4. And I'm going to plug in 2 for x. Right? 5 times 2. Yep, 10. I heard it. My limited Spanish, I heard it. Okay? All the way back to Michelle. Michelle, we're still going to solve for y. Subtract 10 on both sides? Love it. Couldn't have said it better myself. Luckily, I didn't have to. I even get sick of listening to me. I gotta listen to me all the time. Negative 2y equals 4 minus 10. What is 4 minus 10, Michelle? Listen to it. Negative. You forgot the negative part. Okay. I'm going to skip last because he answered last question. Or do you want to answer? What? No? Yeah. We want to solve for what? Love it. Divide both sides by negative 2. What is negative 6 divided by negative 2? Positive 3. Dylan, what do you think step number 5 is going to be? You could literally look. Two blanks that we have to fill. How are we going to write our answer? We're going to write it as an ordered pair. Yes, we're going to write our answer as an ordered pair. Chloe, what does an ordered pair look like? Look back, it's in your notes. I know it is. Watch it. Not great. Your subtlety isn't very subtle. X comma y, exactamundo. We're going to write our answer as x comma y. So how are we going to write this answer, Chloe? 2 comma 3. And then most importantly, Stephanie, what do we have to do? We got to check it, right? Okay. So 5 times 2 minus 2 times 3. 5 times 2 is 10. 2 times 3 is 6. 10 minus 6 is 4. And 4 is equal to 4. Okay, so it checks out there. In checking it in the other one. 2 is 2. 2 times 3 is 6. 2 plus 6 is 8. And 8 is equal to 8. Okay? So we just did all that work. We checked our answer. We got the right answer. Jake, what should we do with it? We should circle it. We should be proud of our work because we done did it right. Okay? Yeah. Let's try another one. Flip that page over. Oh, no, I don't want to do that one. I want to do... I want to do number 3. Because number 3 has a step to do in step number 1. Okay? Alright? Luckily, I gave you the steps right up here, so you don't even have to flip over anymore, right? Okay? So step number 1 says we need to get opposite reciprocals. That's a perpendicular line. We need to get opposite coefficients on one of our variables. So right from the start, because we don't have the same number in front of x's or y's, right? The same digits. Okay? So right from the start, we have to make a choice. And that choice is, do we want to eliminate x or do we want to eliminate y? We are giving you that choice here. You want to eliminate y, okay? Right? So now what's going to happen is this part right here. You may have to multiply one or both of the equations to create the opposites. That's what I want to show you right now. Ash has chosen that we are going to eliminate y. Does it now? Follow-up question, Ash. What if you would have chosen x? Let me rephrase my question. Could have you chosen x? Yeah. Would have it made a difference? No, exactly. Our work might be a little different, but in the end, we're going to get the same answer. Right? Yep, exactly. Okay? You chose to get rid of y. So that means that we have to come up with a number, Wyatt, that both 3 and 2 go into. 6 is a good one, okay? So 6 is our number. Both 3 and 2 go into 6. Meaning they're factors of 6. Meaning that we can multiply by a regular number to get 6. Right? Okay? Done. So I need 6's here now. That's what we're saying. We're trying to get 6's there. Only one positive and one negative. Okay? So I'm going to take this first equation and I'm going to multiply the entire equation by, if I want to get a 6 in front of the y, nope. What times 3 gives me 6? 2. So I'm going to multiply that entire equation by 2. And this is where those, remember when we were doing distributive and we were drawing arrows? This is where those arrows are nice and they come into play. Because it's got to go into all three parts. Not just the left side, not just the y. It's got to go into everything. 2 times 2x is 4x. 2 times 3y is 6y. 2 times 13 is 26. So we get that. Okay. Now, Jaden, we got to do the same thing for the bottom equation. Okay? In this case. Sometimes if we multiply just one of them by it, we get the other number, but in this case it didn't. Okay? So now I've got to multiply this entire equation by a number. What times negative 2 gives me 6? 3. So I'm going to multiply this whole equation by 3. Now I'm thinking ahead too, because remember they had to be opposite, right? So this one, the top one, purple, gave me positive 6. Will the bottom one give me negative 6? Why? Yes or no? Yeah, it will. Okay. If it wouldn't, I would, instead of multiplying by 3, I would have to multiply by negative 3. Okay. All right. So now here, I got to distribute this in here, that in there, and that in there. Okay. So 3 times 5x is 15x. 3 times negative 2y is negative 6y. And 3 times 4 is 12. Okay? All of that in this problem is step number 1. Okay? All of that, what we just did, is all step number 1. Okay? Now, we can go to step number 2, where I can add these two equations. Okay? Plus it. 4x plus 15x. 19x. Love it. Right. Positive 6y plus negative 6y. Positive 6y plus negative 6y, or minus 6y, if you will. 0, right? Because it goes away, because that's what we wanted to do. When Ash chose for us way back when he chose for us the y's to get rid of, we better get rid of the y's then. Otherwise, we're going to let Ash down. We don't want to let Ash down. So these go away. Okay? Cora, 26 plus 12. 38. Love it. Okay? 38. What do I got to do to solve for x, Yasser? 5? We can't do 9. Nope, because there isn't 8. What? Can't do 8. I want to get x by itself. What's the number in front of x? So what am I going to divide by? 19. Yep, I'm going to divide both sides by 19. Okay. Really, do you know what 38 divided by 19 is? It's 2. Exactly, it is 2. Oops. Almost forgot. So that's through step 3 now. Step 4 says we need to substitute that value back into the top original equation or the bottom original equation. Will, which one? Top or bottom?
I think you go.
Bottom one? Okay. Let's go bottom one then. And then it comes up here. You said bottom equation. And so we're going to have 5 times 2 minus 2y equals 4. She gets it twice. She gets the same question twice. 5 times 2. How did that work out? Luck of the draw, I guess. Anyway, we want to solve for y. What do we got to do first? We want to solve for y. Subtract what? No, we can't subtract 0. That's not going to change anything. Subtract, no, we're down here. Subtract 10, yep. Subtract 10 from both sides. That gives me negative 2y equals negative 6. Solve for y. What am I going to do? Whoa, what's going on here? Divide both sides by negative 2? Yep, exactly. Divide by negative 2 there. And that gives me y equals 3. Now we're back to you. How am I going to write my final answer? 2 comma 3. Watch out. What do I need to do with 2 comma 3 now? Check it. So I got to go back to my original equations. Okay. 2 times 2 here is 4 plus 3 times 3, that's 9. 4 plus 9 is 13, and 13 is equal to 13. Works out. 5 times 2 is 10, minus 2 times 3 is 6. 10 minus 6 is 4, and 4 is equal to 4. So it works out. So what should we do, Michelle? We got a circle. Yeah, because we're proud of our work, because we just done did it. And we done did it good. Okay. One more, or turn you loose? All right, do some homework.